Welcome everyone to today's BricsCAD Civil Surveying webinar. We are going to find out together what BricsCAD can do for infrastructure engineers and surveyors with a Pro and BIM license levels. So these are the agenda items for today. We will begin the journey by importing, using, and creating civil surveying points and GIS data. We're going to then use them to create thin surfaces and manipulate them, change the visibility, create gradings, and we will then jump into point number 3. We will insert point clouds and execute the scan to thin process, as well as volume takeoffs. We're going to compare thin surfaces with each other. And last but not least, one of the hottest new V26.2 features, point cloud profile sweep. We're going to show you today how this tool features and how to extract break lines from your point clouds as quickly as possible. So with that being said, let's minimize the PowerPoint and fire up BricsCAD. For anyone that's new in Octave BricsCAD, our solution is a CAD solution, a CAD software. We design in DWG, and BricsCAD is an all-in-one software installation. It means that you install the software once, and then you have access to 5 individual workspaces, which are nothing else than a different user interface that allows us to design in 2D, 3D modeling, civil survey is going to be the focus of today's session. And then, of course, we can create buildings according to IFC standards and mechanical assemblies, all in one software. So we will open up civil surveying and discover what we can do. Let me open up the appropriate file. So we will begin with this one right here. This is the user interface of civil surveying. If you want to change the workspaces, we can do it from the bottom right. We can swap between 2D, 3D, and mechanical and BIM from this little tool set right here. And what we can do with civil surveying? Well, a bunch of things. We can create thin surfaces, civil points, alignments, corridors, and we also introduced the sectioning lines in V26. But by far the most helpful panel and tool in the civil surveying toolset is the Civil Explorer. This is going to be our home. Over here, we are going to get an overview of all the civil entities inside the drawing and additional GIS and settings information. So how do we import points? We can always use this little button right here to create civil points. But in this case, this tool basically allows us to either manually create points ourselves or convert simple CAD points into civil surveying points. This is how we not brand, but this is our technology. The civil surveying points of BricsCAD can carry metadata and information about elevation and attributes. So this is how we create points. But if you want to import the points, we would go on the top side of the panel and import them from a specific point file. So this dialog box appears that asks us for the file. So I want to find the file first. And over here, we have a couple of options. We can either insert a CSV file, text file, CSV Excel file, or text documents. So we can do that in the next step. So this is a CSV file, which if I open it up, you will see the columns and the rows. So what we have is the number, we have the code over here, we have commas, we have northern easting elevation, and a code for the boreholes. So they are divided by commas, no spaces. So what we need to do is open it up and make sure that the preview works. If the preview works directly, we don't need to change anything because the point number is here, easting, and northern elevation. They are available, but if we don't see the preview, it means that we need to change the format. So when is it comma delimited, space delimited? Do we have another description in it? So whenever this comes into play, we can always manipulate the format, define the delimiters, comma into space, and define what kind of columns it's going to read out from the file. So once we do that and make sure that the preview works, we import everything, and voila, we have the points in the modeling space. So once I highlight this, this is a civil point. It's not a CAD point, a simple CAD point. It's a BricsCAD civil point that has northing, easting, and elevation properties, as well as raw point descriptions, point numbers, etc., directly from the files we imported. The visibility can be changed with the help of the settings right here. So to make things simpler, let's close everything down and work in a more organized manner. So under general, we have the symbol settings. So over here, we can pretty much change how the symbols look like. X marks the spot in this case, or we can do the plus icon and decide how it looks like, right? And then we need to change the labels. So the labels, what are we? Civil points, label styles. This is something that we can change as well. So if we go into the components, the text that governs the settings is there. So over here, what we have, the elevation, the number, and description, and we can change the settings as well, colorings, and so on. And the result gives us the elevation, the number, and the borehole description. So with this, in this way, we can insert our civil points and then start creating our surveying plans, or even create a thin surface. So it's a very simple process that allows us to create a thin surface. I just click on that, select them, press space once, and a thin surface got created. So now what we can do with the thin surface, we can use our quad menu, which is a context-sensitive toolbar that identifies the entities and gives us commands that can only be applied for civil entities. So in that case, we can perform simple tasks like deletion of lines. We can remove points. So everything's very intuitive in this case. So feel free to use them at your will. So let's go ahead and talk about the GIS part before stepping into the more advanced thin surface creation and editing. So let's close it down and delete everything once again. And now the question arises, how do we import GIS information? The answer is by importing GIS layer. There you go. These are the GIS format files that we support. And after we select the files, we need to, well, first of all, find the correct folder, GIS data. There you go. Utility. Let's go in and select the shape files or the pipelines and the power lines. Okay, we can see the GIS layers and data imported. And with a double click, I can see the information coming in. So once we select those layers and expand the properties panel, we can see the GIS attributes correctly being carried over. So with this process, we can create very complex GIS drawings for the city planners out there. And yes, on top of that, we can also georeference our drawings. You can see already here on the bottom, there is a GIS coordinate system already applied to this one. And the way to insert it, well, we need the Insert tab for this. We can find the geolocation in this tab. So with this, we define the GIS coordinate system. The advanced settings work exactly like the other CAD platforms out there, so it should feel right at home. And on top of that, once we unfold this little toolbar, we can see the connections we can create with Esri maps. So we can initiate the map connect and connect to VMS services, GeoMap. I mean, we can do all sorts of things when it comes to connecting to maps and geolocations. So this concludes the GIS side of today's presentation, and then let's take a look at a more realistic example, shall we? So this is a surveying plan right? We have our topography lines, we have our civil points, and if I start rotating this, you already see that the lines and points are already in the correct elevation. I used a Lisp routine for that, which can be inserted under the Manage tab, Load Applications. So Lisp is available in BricsCAD. And after doing this, we need the anaglyph of the surface to start working with that. So again, same process, thin surface, selecting everything, hitting the space bar twice, and voila, we have the anaglyph of the surface. Oh, clearly something went wrong here. So what we can do is, well, we can decide to delete a line. So we can pretty much find whatever we don't like and delete it. Maybe this point was irrelevant, so we can delete points and generate a more appropriate geometry. There you go. So the line, the topography line was not correctly placed. So in that way we can correct those changes. And what can we do with this thin surface? Well, again, let's open up the Civil Explorer. Under the civil entities, we can find everything available in the drawing. I don't know which one is it, so I will use this little picker right here to select the surface, number 4. There you go. So we have a bunch of information underneath definitions. It shows us the steps of the creation, statistics, the number of triangles, and the 2D, 3D cubic meters, and the visual styles. This is the one we need. What do we have here? We have triangles open. We can enable the contour lines if we don't have them. And we can also change the intervals. Let's put it to 0.5 just to make it more visually compelling. There you go. And we can always disable the triangle, so the visibility is up to us in the end of the day. So we have a thin surface. So what do we need to do? We need to create a building. We need to do excavations. So what I did prior to this presentation is insert the building plans and find what the 0 elevation of the building should be. So with the form of this polyline, this indicates where the foundation will be. So what we need to do is create a grading to calculate the cubic meters of the soil. So again, a couple of clicks will do the trick. Grading, what do we want? An input entity. The target surface is going to be this one, and I'm going to use the entire length of this polyline, spacebar once again. And now I need to move my mouse just to define the angle of attack. Oh, I'm not hitting it correctly. There you go. So 39, no, I need to do 89. Now, remember, we cannot do 90 degrees because that goes against the definition of a thin surface. A thin surface is a surface, which means that 2 points cannot have the same x, y coordinates and a different z value. So we're restricted to an 89.999 degree declination, which is perfectly good enough for the execution. I will change the visual style and see what we did. So I cannot see anything, but the grading is already here. So how do I change this? I need to select the grading, and after visiting the properties panel, well, I have a bunch of information about the visibilities, but all I need to do is change some settings right here, like the boundary. There you go. This gives me the proper cut and the visibility, and this is apparently the fill area. So we can do the same thing here again. We can change the contour lines, like everything we changed for the thin surface through the Civil Explorer is also available in the properties panel, so you can work as you like. And with a click of the button right here, grading statistics, he will give us the cut and fill volumes of this surface. And the net, what's the difference? Why is it in cubic millimeters? Good question, because I didn't change my units. How to do that? I go to the settings panel, and then under units, let's make sure that the global units are correct. Meters, okay, that's good. But now I need to go into the complete tree view under the drawing units and change the volume units. Okay, I had millimeters before. Let's do meters. right? So make sure you use the correct templates for that. Go all the way down, grading statistics, there you go. What do we have? Cuts over 100 cubic meters and a net volume of 100 something. So this is the result. But if you want to change the geometry, make sure that you select the polyline, because the polyline governs the geometry of the gradings. So we can use the green grips right here to just move it around, and then the software will find the new system, the new solution. It functions very, very quickly. BricsCAD is a multi-threading software, so it generates tins and gradings in a very quick manner. And on top of this, let's check the grading statistics once again. There you go. We have a very massive difference, right? So this is pretty much how it is when we have a fixed elevation. But here is a small trick. If you want to find where your elevation should be, in order for the cut and fill volumes to be the same, so you don't need to bring trucks in and get rid of soil. There you go. Civil balance grading volumes. This is a very interesting tool that balances the gradings and finds where the new elevation should be in order for the net volumes to be 0. So once I do this, I need to input a tolerance. If I put 1%, it will take some time. So let's do 40 in this case. And then the software will do some iterations and try to find what the new elevation should be, so that the cut and the fill volumes are the same, but with a tolerance of 40% in this case. Okay, I hope it will not load for a couple of minutes. Otherwise, I need to bring up some jokes to fill in the the empty and the silence. Okay, just a little bit more. Okay, it does take some time apparently. In the meantime, okay, as it's loading, let me show you an interesting portal on our website so you can learn more about BricsCAD. So once you visit the website, we have an interesting section for you. Under Learn and Support, we have a learning center with lessons, self-paced online lessons that will guide you through the BricsCAD exclusive tools and features. You can log in for free. There's no subscription for that. You can find lessons about the BricsCAD essential tools, V26. You can register, and then there you go. You can find some quick videos about how the exclusive tools work and everything available in BricsCAD. So, okay, let me go through another data set, because apparently that was a mistake from my side. It takes some time to load. In this case, I do have a lot of files open. So let me show you another example. And in this case, we will open up the point cloud. So we already saw how to create a thin surface out of civil points. And now let's see what happens with point clouds. So already from a BricsCAD Pro license level, we have access to the point cloud tab. And over here, we can import and attach point clouds. So this is the point cloud cache manager. And as soon as we select the plus icon, we can insert the point cloud files. These are the file formats that we currently support. The classic E57, LES, LEZ are all available. We will process them into a native BricsCAD format, which means we should have double the volume and the size available in our hard drives. And after this, we will see a small preview over here. Once we click on that, of the actual point cloud. So in this case, let me bring in a point cloud of a real project that was scanned by Leica drones. And I will show you the process we went through to compare the reality with the actual design. So first of all, point clouds. How do we work with them? I highly recommend to right-click and open an additional panel that's called Point Cloud Manager. It came up over here, so I can move it and snap it all the way to the right. And I don't need this filter. So there you go. We have the Point Cloud Manager, which gives us the regions and the classes in case you decide to classify your point clouds. And then we have the rendering settings. So we can decide how many points are simultaneously visible in the drawing. So if you're encountering performance issues, drop it down to 5 million, but it goes all the way to 50. And then the classical point size, gap filling. So there are a couple of options right here. If you're working with massive point clouds, I highly recommend to create regions, which are pretty much areas of interest, so we can isolate them. I can draw a region as a rectangle, let's say right here, and he will identify those points. And after finishing it, I can type in a name, test, and I can hide everything else. So I can work only on the interest areas right here. So what can we do with this point cloud? Well, the same thing applies. We can do thin surfaces. In the command line, we can create them from the point cloud. Okay, so I select the point cloud. I will say no to the simplification. I want to use all the points available. And due to the large number of points, the visibility was set to boundary line only. No worries. We can go to the property settings and just enable the triangles over here. So once we enable the triangles, we will see the actual thin surface. There you go. So once we zoom in, we'll see the result. Every single point was used to create this point clouds. And sadly, construction site vehicles were also part of the scan. So there are a couple of ways to get rid of this noise. We can, of course, use the thin surface tools. We can remove points manually, which, well, I wouldn't recommend this. It takes some time. What I would recommend is this, a smoothening tool, which after inputting a radius, it creates a tool that finds the middle area and pretty much like a makeup tool gets rid of the unnecessary noise. So there you go, with just a couple of clicks, we got rid of the car, and we need to make sure that the rest of the surface gets the same treatment. So with that, let me go into this file and show you what we actually did. As we saw, we're working with a point clouds, and we created a thin surface of the actual site, right? So this is the reality on the one side. On the other side, this is the project that we need to achieve. This is the actual design, right? Your 2D plans, your 3D thin surfaces. So what we can do is enable them, both of them at the same time. Well, visually, we can identify the difference pretty easily, but okay, what does this mean? What do I need to excavate over here? So the answer lies under thin volume surfaces. So what we can do in this case, we need to define some areas of interest in the form of polylines or rectangles, just to make the software's life easier. So I want to focus on this area. And after triggering this command, a comparison will appear on the X and Y plane, which gives us, well, red is excavation, green is filling, right? So we can go into the thin surface volumes over here and find the cut and fill volumes, the areas in 2D and the 3D areas as well. Well, millimeters as well. We should change the units, but in this case, we do have a very quick way of calculating the volumes. And then with our command data extraction, we can extract a table out of this thin volume surface. And I'm pretty sure, there you go, we have a new command, thin volume report, that does the job much easier. So if we click on this thin volume and pick the table insertion, there you go. We have the surface and the volumes in a very easy to use table. And in the end, once we're done with this process and the thin surfaces, what BricsCAD Civil Surveying can do is help us create corridors, roads, and calculate their volumes. So this is an example right here. What we did is we utilized 2D profiles, and with the help of the corridor command, we applied materials. So if I select the template, we can see right here, every shape, if I cycle through, has a specific code and a material, and we can define the angle of attack until it reaches the thin surface. And then with the help of horizontal and vertical alignments, we can apply the corridors onto our project. We can hit the thin surface, we can calculate the soil, and we can calculate how much asphalt we have in the whole project. And on top of this, we have the cubic meters of the lake, and the project is complete after setting the buildings. Low LOD for the time being, but BricsCAD BIM is another discussion. We can create buildings out of those representations as well. So with that being said, let me go back. Apparently the drawing doesn't like me today. We had a small error. And I would like to highlight the fact that BricsCAD is a platform. That means we support over 400 third-party applications that do very advanced infrastructure projects. In this example, we are showcasing some data sets from CGS, Platia, and Ferrovia. They do intersections, infrastructure projects, and even tunnels, which we cannot do with native BricsCAD. So feel free to discover the third-party applications by visiting either our website, or if you can find them on the starting page under apps. So these applications can be found under our applications catalog. So if you're into civil surveying, if you click right here, you will get redirected to the specific category in our applications catalog, and you will find all the necessary apps that were used for these data sets. So this is what we can do in infrastructure and surveying. And now let's take a look into our hottest new tool, the Point Cloud Profile Sweep. This is a new addition that makes the life of surveyors so much easier, because if you're working with infrastructure projects, road creations, train, railway stations, you will need eventually to compare your design with the reality, or even capture the reality and create a model out of it. So what is absolutely essential in this case, so we can see the roads and the pavements, we need to trace the break line of the pavement in that scenario. So let's see how that looks like. I can zoom right here. I can enable the Point Cloud Profile Sweep. And first thing I need to do is hit one spot on the first corner, and then find the point on a second corner. So this is a new tool that gives us a direct slice of the point clouds. I can make it smaller. I actually need to make it smaller because this will give me the highest resolution of the point cloud right here. And then I can go into this tool, and I need to hit some points. 1, 2, 3. Well, you see a lot of, with the right click, I can remove them. You can see a lot of points right here because the thickness is a bit too big, so I can make it smaller or bigger if we need to. There you go. Can get rid of the e-snap. There you go. So we can get a nice little slice. And then I select my surface. All right, a couple of points. So what he does, he directly creates a profile, some lines. The geometry can be lines or polylines or surfaces in the end of the day. We can see how it looks like. And the output are either the profile lines or the key point lines. Let's keep both. I will then define the accuracy. Let's leave it at 80% deviation from the targets, and the step size. Let's do every 30 centimeters because it will run along the pavement and find and attach those profiles. So I can also lock the camera to this tool and then run multi-steps. So he runs along the pavement and adapts the profile and the lines according to what he finds. He stops when the deviation falls under the acceptable accuracy levels. Very impressive tool once you see it going. Okay, there you go. We need to pay attention right here. Okay, let's stop it because I clearly saw some deviations. So we can go back the steps and zoom right in and figure out what went wrong. Okay, because right now what we did is created all those profile lines. So what we can do is change the output from step lines. This is the actual break line that the surveyors need. And well, this is the profile, right? But we can always keep both if necessary. So we can go back in time and examine every little step, and we can dynamically change the geometry. So what we can see right now is me changing the geometry live in the modeling space. So those tools are connected with each other. So it is a little bit of a manual process in this case, but you can go in and change the geometry as much as you like. At the end of the day, hit apply, and we get a representation of the pavement. There you go. We have 3D polylines. We can isolate them. And this right here is the $1 million polyline that every surveyor needs. Brilliant. So this is a great example for the road makers out there. So let's see another one around train stations. Same principle applies. We want to find out the break line of this platform right here. So I will not make it a lengthy example. I will just show you the same steps, 1, 2, 3, let it run, and it follows along. Oh, it went away, so no worries. I can anytime click this little camera and it follows the movement. And okay, let's pause it, hit apply. Very simple example. We don't have a lot of strange curves, but I would like to close today's session with a very interesting tip and trick about this tool. I recently found out that we can also trace cables. So there you go. Look how it looks like. 1 click, 2 clicks. Let's make it smaller so we get more detail out of that one. And in that case, well, let's just do a dot. And step size, let's do every 0.5 meter. We're in millimeters, okay. 500 millimeters. And what happens if we do multi-steps? There you go. Just goes around and follows the cable, traces it, and follows the curve. Exactly. Perfect. It stops right there. So after we hit apply, there you go. We have the cables. So this, ladies and gentlemen, is point cloud profile sweep. One small tip, we can also do closed polyline. So if you want to trace a column, we can hit this right here and connect the first to the last. So we can trace profiles as well. An upcoming tool will allow us to create pipes. So there are a lot of things in development right now. So make sure to stay tuned. And yeah, that was BricsCAD Civil Surveying for you. Thank you very, very much for your attendance, and thank you for bearing with me in this lovely Friday. And let's take a look at the chats, shall we? Please feel free to ask away any questions you might have. We'll take a closer look to the Q&A, and the questions we will not be able to, we won't answer today, we will gather them and we can send you the answer per email. So we have, oh, an interesting question about coordinate systems. We can work third quadrant and importing text. Oh, that's a very heavy one. Let me do my homework for this one. and you will get the answer per email, sir. Can BricsCAD calculate separate earthwork volumes for different substrate layers beneath a top thin surface? Separate earthwork volumes from different layers beneath a top thin surface. I'm not sure I understand the question correctly, but if you're talking about multiple thin surface, the calculation gets executed only between two thin surfaces. I'm pretty sure I understood the question wrongly, so please correct me. You show the tools methods available to elevate 2D polylines to 3D for site grading. Elevated 2D polylines. Well, I need to share my screen again to elevate the 2D polylines and make it 3D. Well, the thing is, if you're working with 2D polylines, okay, let's do one. PEL for polyline and C for close, right? This is a normal polyline. A 3D polyline, it means that not every point shares the same Z elevation. It means that all of a sudden one point goes right there. So there are two legs in this question. First leg is how to put it in the correct elevation. The answer is through the properties panel. We have an elevation section, so we can type in our elevation in millimeters or in meters, and then elevate it, right? But the second leg of the question is how to do a 3D polyline. The 3D polyline, well, we need points to be in a separate Z elevation. So I'm not sure I know the commands, but in this case, let me show you a small trick. We have the BricsCAD Assist in the v26.2 version, which is our new little chatbot that serves like a knowledge depository, if you may. And the question is how to convert a 2D polyline into a 3D one. Okay, searches the help center, and it will give us the correct commands. So the answer is convert poly, okay, and choose 3D poly. Okay, so convert poly, and get this out of the way, convert to 3D poly. There you go, that's a 3D polyline. So now each individual vertice can be controlled, and there you go, you can create a 3D polyline now. So make sure you use the BricsCAD Assist, very helpful. So stop sharing, there you go. Is profile sweep function only for BIM version? Yes, unfortunately, this is a BIM license level feature for the time being. Could you do a profile across the whole road from curb top to curb top? Want to try? The problem in this case is the resolution. Where am I? Footprints, there you go. Road pavement. Okay, let's get rid of those polylines and try it together. Okay, so again, the problem is we're deviating a lot from area to area. So let's do it right here, or let's find an appropriate way to do it, appropriate area. Now here's the problem. Once we insert the profile sweep, let's do it somewhere here in the middle, right? The bigger the section, the smaller the resolution right here. So I highly recommend doing it in segments, because once you create a big section, you cannot be very sure where the line is. So we don't recommend this because the software is not going to find the best solution. Look at the resolution right here. He's not going to follow it correctly at any point. But if you make it smaller, as I showed before, the resolution is going to be much better. So unfortunately, it's just an accuracy issue. Okay. Okay. A tool to rename points with number, point A, point B, to rename point names with numbers. I'm pretty sure this is a Lisp routine task. Phil, make sure you search for the auto mapping. I will do the homework for this one, but let me write something in the chat for you, because we have a new feature called auto mapping in civil surveying. And with this tool, we can define a rule of the points and do a batch switching of the attributes. Let me find out the how-to video afterwards. So intersections, a curb returns in native BricsCAD civil corridor. Unfortunately, the functionalities of civil surveying with pure BricsCAD, they're relatively simplistic. So we cannot do intersection and such designs. Let me share something in my screen. I will also share in the chat. There is another civil webinar that lives on YouTube, and over here you will see a corridor example. So we can slice the tin surfaces, we can calculate the soil, we can do different profiles and different lengths, but we cannot do intersections with BricsCAD's native tools. So we will need a third-party application for that. Okay, we made a good time today. Thank you very much for the questions. I see very complex ones, so please allow me the time to do some investigation to answer everything properly. So thank you very much for your time on a Friday morning, and enjoy the weekend, everyone. See you around. Feel free to reach out to us if you have questions, and see you in the next one.